The theme of this conference has been agentic engineering. And as you heard from some of our investors, uh, voice AI is not only a hot area of investment, a really cool new technology, but it's one of the areas that I think of first when I think of hard agentic engineering challenges, especially when it comes to infrastructure. So I'm really delighted to talk to Russ, founder of LiveKit, who one of the leading players in voice AI, uh, and Sam. So, Russ, maybe just to get started, can you give a quick intro of who you are, what you guys do, and then for the founders in the room, kind of the size of your and scale of your current company?
Size and scale. So I said,
Yeah.
so, uh, so CEO of LiveKit. LiveKit is both open source kind of infrastructure for building agents that you can interact with like a person, so they can see and they can hear and they can speak back to you. And then also the runtime infrastructure. So you build agents using our frameworks and SDKs, and then you can run those agents around the world on our infrastructure. Um, Started in a very different, well, not very different place, but in a different place as network infrastructure during the pandemic. Um, but fast forward to today, we do a lot more than just network infrastructure, kind of like an end-to-end platform that does pretty much all of the parts that are important across building a voice AI or a computer vision-based AI application, a physical AI application, which is kind of an application of both of those things. Um, and yeah, we're operating at a really massive scale. So, OpenAI built ChatGPT voice on top of us. I think that's the thing that we got most well known for a few years ago. But now, Grok voice runs on us, all Tesla call centers, service centers, Starlink service centers, Spotify, runs on us too for a lot of their live content and
That's
agents
awesome.
there. Yeah, it's a lot of scale.
So can you walk through a little bit of your infrastructure? I think you've made some like really interesting infrastructure choices to serve your particular sort of use case.
Yeah, for sure. So, maybe like let me motivate it first, and then I'll kind of walk you through the why of it. So we started as an open source project during the pandemic, and the pandemic was this moment where you needed to do a lot of streaming audio and video because you couldn't see people in real life, so you had to do it over the internet. And the internet, most people I have this line that I say a lot now, and I think it resonates with people, is that like the web isn't built for streaming audio and video. HTTP is the hypertext transfer protocol, not the hyper voice or video transfer protocol. And so you need a different protocol called WebRTC, Web Real-Time Communication, and that protocol was built for streaming audio and video over the internet. The issue is that that protocol is not built for scale. It's a peer-to-peer protocol. And so you think about the pandemic and the scale at which you were connecting with people around the world during the pandemic, you actually have to build a lot of infrastructure around the protocol to get it to that level of scale. And so why were you using Google Meet and Zoom and Discord? Because they've all built infrastructure for 10 years around the protocol to get it to be able to scale. I was working on a side project. I needed to stream audio and video, and my options were a really expensive thing like Twilio or something DIY, because actually in open source there wasn't anything. Just no demand for audio and video streaming until the pandemic hit. So there's no open source. And so started to work on this infra to support my side project. Side project was a bad idea. Open source ended up blowing up and becoming very popular. And so, we had large companies starting to use it, and they were saying, hey, where's your commercial cloud version? We want to deploy this all around the world, have a global network, kind of like Cloudflare, but for media streaming. So can you build that for us instead, and we'll pay you? So we raised a round, started a company, started working on this commercial product, spent 2 years working on this amazing piece of tech. ChatGPT comes out. I'm like, wow, it's like texting with a person. So I'm like, well, what if I took LiveKit stuff and I made a demo where instead of texting with the computer, I talk to the computer? So we built a demo, first multi-turn real-time conversation with an AI model as far as we know, um, and tweeted out, think I'm going viral, and 100 people like it, and so that was sad. But 5 months later, OpenAI found the demo, read the blog post, signed up in secret with a personal Gmail address so we wouldn't know it was them, and they built ChatGPT Voice on top of LiveKit Cloud. And it was at that moment, actually. So that was in August 2023. September 2023, at the end of it, is when ChatGPT voice launches. And um, OpenAI puts a meeting on our calendar like a week before it launches. And so we go in there, it's their entire DevOps team. They're like, so how do we deploy and scale this? And I'm like, what do you mean? I'm like, you're OpenAI, why are you asking me? And they're like, well, it turns out that this is actually like very different from a web application. So like an application, a computer that you can talk to like a person, um, when we talk to each other, this is a continuous process. I am speaking, you are at that moment taking my speech in real time in a streaming fashion. You're also integrating what I'm saying into your world model. And then you're also deciding in real time whether you should interrupt me. If it's a one-on-one conversation, you're not going to do that right now, but whether you should nod your head, etc. All of this is continuously happening for as long as we're going to talk here. That's very different from how a web application works, where it's a request response. It's like discrete computing versus continuous computing. And so it turns out that you have to build that application differently. OpenAI was asking us how to deploy it because you have to load balance it differently. It's more like load balancing Fortnite than it is load balancing a web app. And then it turns out that you can't even like test these applications the same way. You can't like run them. You need like to optimize latency across 3 different models, not one model. So you need some kind of gateway or routing system to handle that. And then you can't even observe the application in the same way. You have to understand like how a conversation breaks down with the user. Our tool is called in the right order. Did the STT understand gastroenterology when you said it the first time? Did the user hammer the 0 button for a phone call? And so every part of the development lifecycle has to change and be reimagined for a stateful world, not a stateless world. And so because none of it existed and OpenAI kind of like manifested this into existence, and we just luckily happened to be there behind the scenes with a front row seat, um, we decided, well, how can we make building stateful applications, this new paradigm, as easy and as familiar as building a web application is for people? And so we started to work on every single part of the stack. So the agents framework on the build side, testing and evaluation and simulation, a full deployment stack, so like our Vercel to the Next.js equivalent in the analogy, a gateway, selling our own phone numbers, partnering with carriers around the world directly, and then, of course, like our own Datadog for voice AI, so a real-time way of observing how users are interacting with the AI model.
That's wow, that's awesome. A lot of people want to build agents, customer-facing agents, and have voice as a main modality. You take care of a lot of the infra stuff, I guess. But what are some of the infrastructure, I guess, challenges that founders should think through that might be surprising to them? Uh, yeah, what would you suggest that they think ahead about and think and architect around?
I think voice AI is like a fundamentally different UX than you're used to, right? It's not clicking a button, filling out a form, etc., waiting for a response. It's actually even very different from just like a chatbot. Your prior for texting with a computer is texting with a person. And so you don't expect a person to respond to you right away. You don't even expect the typing indicator to show up immediately. But your prior for talking to the computer is talking to a person. And for decades, you have been conditioned to expect a response in 250 milliseconds of latency or less than that, if it's English. It varies, but it's pretty low across languages. And so the first thing that I say is that I think is a surprise for most people when they're building voice AI versus kind of like the web application paradigm is that latency is not an optimization for that type of application. That category of application, latency is critical path. So you have to be thinking about how do you architect for latency, right? To reduce the overall end-to-end latency. And there are multiple spots along kind of like that chain of things happening that contribute to latency. And so you have to kind of, well, or you can rely on LiveKit and we optimize a lot of it for you. But there are still, even like if you use LiveKit, there are still places where you have to think through your UX and think through the category of application that you're working on as well. So what do I mean by that? To put that concretely, certain types of use cases in voice AI are more sensitive to latency than other types of use cases. So, for example, uh, ordering food at a restaurant is actually highly sensitive to latency. Um, I know DoorDash has been experimenting with like being able to do voice ordering from the app directly, and as soon as, and also over the telephone. And as almost when they were testing their initial versions that had a bit of a higher latency, every single time the person was hammering the 0 button to just like stop talking to the AI, or like if it was a prompted, a voice prompt, it'd be like AI. I mean, human, 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 human. And so,
Was that in the 250 millisecond thing, or?
oh, I mean, I would say like right now we're like not close to 250 milliseconds. Like nobody is really. You can get the latency quite low if that's all you optimize for, but latency and quality or speed and quality are a natural trade-off always. And so you can like have STT, LLM, TTS, the agent and the user all co-located in the same region of the world, all of the models running in the same data center. And maybe the lowest you can get it down to is like 500-600 milliseconds maybe, but you can get it lower than that. You can get it lower than that, but you have to use a really dumb model. Like the thing is going to hallucinate. It's not going to follow instructions. It's not going to call tools all the time. And so there is this natural trade-off. If you want to use kind of like the typical like best in class models, maybe not like the ones that orient towards reasoning, but kind of middle of the road, high intelligence, but not thinking a ton. The lowest you can get that down to, practically speaking, is maybe, well, you'd have to, yeah, if you could co-locate it all, you can maybe get it down to 700, 800. Typical though is like 1 to 1.2.
So are there like UX things that you can do to, like, I don't know, you have the model say something I'm thinking or whatever, design kind of experience things you can do to mitigate that?
Yeah, a pattern that a lot of people are starting to use now for these kind of contemporary voice AI applications are, um, they'll use this thing called fast brain, slow brain. And so they have a tighter, faster model, still a certain size so that you can get like a decent amount of intelligence. Like a lot of like the open weight models are pretty good at this, but like you have a fast brain that is processing the audio, kicking off like a sub agent or sub process to go in to a more heavyweight reasoning model if it has to do a bunch of thinking or work. But then it also can respond to the user right away. And then configuring how it responds is is also something that people work on. Like it has to respond in like a believable way as well.
Yeah, yeah.
And like saying I'm thinking can work. Another thing that people do to kind of trick the user, not in a
Not
not in a nefarious way, but
Yeah.
you can create the perception or like something people used to do in like Web 2.0 apps, right? Is they would do optimistic like UI updates,
Right. Yeah.
and then like revert if there's an error on the back end. The kind of like, yeah, I don't know if it's equivalent. It's not equivalent to that, but it kind of like reminds me of it. Is people will play like these pre-recorded audio
Yeah.
sounds
Like an
as an interim or in the background. So it's like typing,
Right.
or they'll play some static even, such that it's not pure silence. And that goes a long way. It goes a long way because you expect like to hear something,
Yeah.
right? To give the illusion of presence. It's not so much that you have to say words. It's more about that there is something or someone there that is like, yeah,
Yeah. I heard
communicating
you.
presence.
Yeah.
Yeah. I'm in their environment or something like that, right?
Yeah. So where are we? Like, what is the state of art for voice AI today? And then, as like a corollary to that, what applications do you find most compelling? Like, there's a slew of startups doing like pick up the phone for auto dealerships or restaurants or drive-throughs. But yeah, where do you see the most applicable use cases?
Yeah. So I think there's state of the art and a lot of like the kind of exciting, somewhat sci-fi use cases are kind of in that bucket. And then there's all the like use cases that make really great businesses right now. And so in that category, it's effectively like any workflow that happens on behalf of a business through a telephone call, right? So the telephone system is a voice native system. It's voice in, voice out. There's no screen usually. Um, and uh, and so millions of calls around the world are being answered by a human today on behalf of a business. And so
Can you give us like a concrete example?
yeah, sure. So like I mean the obvious one is customer support. That's not really even a vertical though. That's like a horizontal. It spans many different verticals. Verticals though, so in healthcare, there are things like patient intake at a hospital is a really common one, where you're calling like the gastroenterology department and trying to get onto the doctor's calendar. Um, Another one is this is an outbound use case, but insurance eligibility checking. So patient has some procedure they need to get done, and the hospital calls the insurance company on behalf of the patient and runs through actually a 45-minute long set of questions. This is for a human, a 45-minute long back and forth between two humans to verify all the proper encoding of that procedure and that it's covered and all of this stuff. There's like clinical note taking in a doctor's office. That's not telephony based, but that's another healthcare based use case. There's auto loan qualification in FinServe. There's like wire confirmations. There's basic like financial advisor type of services. There's actual bank transactions over the telephone. So like there's a lot of these.
Yeah.
And so building voice AI that can go and replace the human for these phone calls is now starting to scale up and prove to be very lucrative. And it's a great business for a lot of folks. I haven't answered the state of the art question, but
No, that's great. Yeah.
yeah.
So on the company side, you're in this like really interesting type of company where you have a open source framework and then a platform that's built on top of that. You've, this is your fifth company, and so I'm curious, like, what are the unique or interesting things to you about sort of like this kind of like open source dev tools?
Well, one question just to build on that is there's always the question of like what to include in the open source and what to like gate.
Oh yeah. Yeah.
There's all these company building questions when it's related to open source.
Yeah. How honest should I be with this one?
Safe space.
Well, I think it's really tricky. So what makes it, well, okay. So I'll just tell a real story. When we started, we had LiveKit open source. It was a media server. It was SDKs. You could put that media server somewhere, and anybody could connect to it. And that was cool, right? You could connect a bunch of users to it, but that media server didn't communicate with other media servers if they were deployed somewhere else. And so what ends up happening is you can vertically scale that type of architecture. You can't horizontally scale it because the servers don't talk to each other. And so what was different between LiveKit Cloud, our commercial product, and LiveKit open source was that the servers, the proprietary part of LiveKit was that the servers could intercommunicate in the commercial version. And so they form a global mesh network fabric, and all these servers make real-time routing decisions to move media as fast as possible between any of those data centers around the world. And so it's a significant, piece of our stack, and probably more code in aggregate than all of open source combined. And we have a lot of open source. And so during the pandemic, video conferencing, live streaming use cases, if you had any kind of real application, you need to connect 50 people all around the world for an all hands, or you need to stream you playing a video game for like 5 hours to 10,000 people. All of the shapes of these kinds of use cases at scale require you to use cloud, right? Cloud is like a painkiller, not a vitamin. In voice AI, it actually ended up being a little bit different. 99 point whatever % of people still use LiveKit. Well, let me explain. So when we were just network infrastructure for voice AI, what we were seeing was more people, like a lot of our competitors are actually built on LiveKit underneath. You just don't know it because it's all LiveKit open source. And back then when we were just network infrastructure, people could get away with taking our open source server and deploying it and like connecting some people to it, because most of those conversations are just one-on-one. It's a human to the AI. And so you don't need the servers to interconnect. You just put servers all around the world. And they all just run in isolation, whichever region they're deployed in. And so one thing we thought about was, well, we need to turn LiveKit, the cloud platform, into more of a painkiller for voice AI than a vitamin. So how do we do that? Well, it's all of these other pieces of the stack, right? Testing, simulation, evaluation, cloud only, deployment and auto scaling, cloud only, all the SIP telephony stuff, partnering with carriers, being able to do large numbers of concurrent phone calls, which is a really hard thing to do, load balancing telephony, also cloud only. The inference gateway for doing all the model routing with as low latency as possible, cloud only. All the observability, cloud only. And so
But is any of that like specific to voice? All the things
well, it's not specific to voice, it's specific to stateful computing.
state.
And so like it's like, you know, when you talk to the computer, you need to have a full transcript of what was said. But then imagine if like you're using LiveKit to teleoperate a robot, you need to have like a full picture of like everything that robot saw, everything it heard, what actions it took and when and why. So it's not voice specific. It's more about real time audio, video as the input, as the IO specific.
Yeah. Sam, you're building an open source framework. Do you think about it the same way? What to gate, what to not?
Yeah, I mean, it's the thing you think about, I think, constantly. When you and figuring out, and there's sort of like, it's interesting to hear for different domains like what the natural sort of like cleavage is between the bits. And for you, I guess that was like video to voice and like single server to multi-server.
Yeah, I should also add though that on the kind of like what is cloud, what is open source, um, all of the core things we've built, we try to put back into open source. So all of our SIP telephony stack, just not the load balancer, is open source, right? All of our models that we've built for turn detection, for barge in, all these things, they're all open weights. So we try to put as much as we can into open source, always by default. Those are our roots. We started as an open source project. We didn't create an open source project as like some kind of marketing stunt to get people to use LiveKit. And so, we know where we came from and we always try to put the value in, but we also, the only way to continue working on the open source is to make it sustainable and build a business. So we have to make some strategic decisions to to create that sustainable flywheel. Yeah.
Can you talk a bit about the models that you've trained and what the process was like, sort of moving from an infrastructure company to an infrastructure company and a lab?
Oh man, that's dangerous. We're not a lab, just to be very clear. We do train models, but we don't train kind of the foundational frontier models. We train small models. And maybe I'll tie this back to kind of like state of the art in voice AI. So I think the future is ultimately, how many of you are familiar with the thinking machines interaction model that they announced a few weeks ago? Yeah, so it's pretty awesome. Really, really, really great work from them. And I think like ultimately the thing that they're working on, right? It's not there yet, and it's going to improve over time and all of that. But the kernel of what they're working on is ultimately how I think it's going to be shaped, right? You're going to have a single model that can take in any combination of modality and generate any combination on the output side. And it's going to take some time though to be able to create a model like that that has the level of intelligence of like some of the frontier kind of LLMs today. There's not as much training data, and so it's going to take some time to get that right. And in the interim, let's say that it's like, I don't think it's something that's going to happen in like 6 months. It's going to take a few years. In the interim, you can actually use all of this stuff now to build amazing businesses. And especially in voice AI, you can build some really awesome stuff with the existing technology. And so, but to do it well, you actually need more than just speech to text, text to speech, and an LLM in between.
Yeah.
There's the intelligence of it. There's converting the modalities into the modality that the model takes natively as input. So speech to text, goes into the LLM, LLM generates text, that goes back into text to speech. So there are those things that you need as like table stakes. And that's kind of like called at the core intelligence kind of cascaded pipeline of models. You also need conversational intelligence. So you have to understand some of the things that humans just naturally take for granted. You know, they understand it in their brain from talking with other people since they were born. Well, not since they were born, but you know what I mean. And and those are like things like turn taking. How do you know when someone is done sharing their thought, when it's appropriate for you to speak, interrupting someone or barge in? How do you know when something is truly a barge in or whether it's just a back channel, right? So you say something to me, you nod your head. That's just like a back channel. Or you say, okay, on the phone, that's a back channel. You may not be interrupting me, or you may be interrupting me. It depends on how you say it. And so, like, where does that conversational intelligence come from? Like these core models I mentioned don't do it. And some of them are starting to. So some of the speech to text models are starting to integrate turn taking into it, turn detection into it. The problem with that is it's awesome that you can make this prediction across two axes from the same model. The issue is that you now have like tightly coupled your transcription kind of quality with like turn taking. And ideally, you actually want those things to be separate so that you can swap out for a better speech to text or transcribing model while maybe not compromising on the turn taking ability. And so yesterday, actually, we just launched our latest version of our turn detector, and it's state of the art. It's outperforms basically everything in this open benchmark we also released alongside it yesterday. And what's interesting about that model, just diving into it a little bit, because it's probably the coolest one we have so far. Our Bargain one's also pretty cool, but the turn detection model, when we first launched our turn detection model in 2024, it only took into account two things. It took into account whether there was someone speaking or not, so voice activity detection. And then it had a semantic layer. So what were you saying? And that covers a lot, but the big miss is that it's not just what you said that matters for turn taking, it's also how you say something, right? I'd like to order a pizza. I'd like to order a pizza and garlic bread. You know what I mean?
Tonality, the tonality, yeah.
And so you know, there's a difference there. And so how does the model understand that difference? And so you have to incorporate both semantic and acoustic into the same model. And so this model that we put out yesterday does that, where it's kind of continuously processing audio at the acoustic layer. It's also looking at the text, but not using transcription. So our first model used transcription, which meant that you had to wait for transcription to run before you could actually make the semantic prediction. Now what it does is it actually maps what you're saying, the audio tokens, directly into the text space of an LLM. And then so it can make the semantic prediction without having to go through speech to text. And so, yeah, I mean, this is just one of the stuff that we try.
That's amazing. I mean, I would encourage like all the founders of the room to think about voice use cases. You know, I have the privilege of well, being a VC in my prior life and also scouting, and I know that all VCs right now that are actively investing in AI are investigating voice AI use cases specifically. And there's just, like you just heard, there's a lot of very nuanced interaction UX kind of things that you need to figure out, even if the infra is taken care of by LiveKit. But please join me in thanking Russ. Thank you for coming.
Thank you.